For section 3, we're going to be converting time and temperature and other measures that kind of fall into that. So we're going to kind of, for a minute, step away from length and weight and volume, and we're going to talk about converting time and, like I said, temperature. Those are the two main things that we're going to focus on. We did do a little bit of this in a previous section when you guys were doing like dimensional analysis, where you had to convert, like we had one example that was feet per second. We wanted to convert it to miles per hour. So we have done a little bit with time already, but this is going to mainly stick to just going between days and hours and seconds and those kind of things. The nice thing about time is that it's consistent all over the world. So there's no two different types of measurements for time, whether you're in a country that deals with the metric system or not. Time is the same everywhere. So that is one nice thing about time, is we don't have to have a bunch of charts that talk about all the different things. So let's just do one example here. We want to convert 3 hours to minutes. How would you guys do that? Yeah, just take 3 times 60, because we should know that there's 60 minutes in 1 hour. And what would that be? 180. So there's 180 minutes in 3 hours. So the next one here says that a technician can assemble one pre-cut picture frame in 7 minutes. How long will it take to assemble 25 frames? What would you guys do for this one? Right, just take that 7 minutes times 25, because it's 7 minutes for every one frame. Now, if it was like 7 minutes for 2 frames, then we would have to maybe set up like a bit of a different problem here. But every 7 minutes, he gets 1 frame done. So we're going to do 7 times 25. So how long is it going to take him to do that? Got 175 minutes. Or how many hours would that be? 2 hours and what? 55 minutes. So almost 3 hours. Just under 3 hours it would take him to do that. Now, if it doesn't say to convert it to hours and minutes, you don't necessarily have to do that. But if somebody was asking you, like how long they thought, or how long you were going to take to do a certain job, they're probably going to want to hear you say something like 2 hours and 55 minutes versus 175 minutes. They're not going to want to have to think themselves about how long it would take you. So it might make some sense to switch it to hours and minutes, because it makes more sense to us when we actually think about time moving. How long is that going to be? Now, temperature, just like our US system is a little bit different than the metric system, there are some places that like to measure temperature in Celsius instead of Fahrenheit. Those are like the two main ones. We also do have Kelvin. Kelvin is used a lot in a metric system, but a lot of times it's used more like in the science type world when you're measuring the temperature of like certain elements out there. So Kelvin is a scale that's used in the metric system to measure temperature. The abbreviation for that is just a capital K. So capital K stands for Kelvin. Celsius is probably the more common measurement that we would see for temperature in the metric system. And so that one we do like the little circle and then C, because that represents degrees Celsius. And then for us, what we're used to would be degrees Fahrenheit. So a little circle and then a capital F. So the most common conversion that we would have to do with temperature is to go between Celsius and Fahrenheit. There's even some things out there, like if you go to the grocery store and you buy certain foods, it'll say, you know, on the back, like preheat your oven to 350 degrees Fahrenheit. Take a look and see if sometime it has next to it what would it be in Celsius, because they do sometimes label it both depending on if that product is distributed to the States and maybe even to Canada, because Canada measures in Celsius. So those would be things that you could even just see in everyday life, where you'll see those two measurements, because it could be distributed among 2 different countries and they're not going to separate them out like that. If you're trying to go from Fahrenheit to Celsius, there's a formula that you can use. You're going to take 5/9, so the fraction, And you're going to take that times degrees Fahrenheit, so whatever the Fahrenheit degrees are, and you're going to subtract 32 from it. So that's going to equal degrees Celsius. So for example, according to Dr. Wimberly, an antifungal powder containing tolnaftate, I don't know if I'm saying that right, may be stored at a room temperature of 77 degrees Fahrenheit. They want us to change it to degrees Celsius. So I'm going to take 5/9 times, I replace my degrees Fahrenheit with the number they're giving me, which is 77, and then I subtract 32 from that. So you might want to subtract first, take the 77 minus the 32 to get you started, and then take it times 5/9. You could also subtract first, multiply by 5, and then divide by 9. I want you guys to do that and tell me what this would be in Celsius. Should come out as a whole number, no decimal. What do you guys get? Good, 25. And then we would say degrees Celsius. So then we also have a formula if we want to go the other way instead. So if we have something in Celsius and we want to get it to be in Fahrenheit, we have another formula for that one. It looks really similar to what we just did, just a couple things are different. So to find something that's in Celsius and to get it in Fahrenheit, instead of doing 5/9, you're going to do 9/5. So that fraction flips upside down. Now you take that times degrees Celsius first, and then you add 32 to it. And that's going to equal degrees Fahrenheit. So the label on a dropper bottle, I'm not even going to try to pronounce those words. Solution warns that the medicine must not be stored at a temperature above 25 degrees Celsius. We want to change it to degrees Fahrenheit. So I'm going to take 9/5 times 25 and then add 32 to it. Now you guys could use your calculator, or if you've noticed anything about this problem and the one that we just did, you may not even need a calculator, because what are the degrees going to be in Fahrenheit? 77. Okay, the last problem was 77 degrees Fahrenheit, and we went to Celsius, it was 25. No, this is 25 degrees Celsius, and you're going to Fahrenheit, so it should just go back up to 77. You can check it. Okay? So that's how you go in between those temperatures. It's fairly simple. You just got to plug it in, basically, and then let your calculator do the rest of the work for you. Now, some other measurements, and these are kind of random measurements, not necessarily ones that you're going to see a whole lot of. But these kind of just give us some other measures that we maybe haven't talked about specifically and what they would be used for. So a lot of times, like if you guys are reading through some of the story problems that you have to do on some of your assignments, they might use a word that you're not sure what that would even be used for. This chart may help you with some of that. So like if you didn't know like what a joule stood for, Joule, that is for energy. Or watt would be for power, so how many watts something has. So they've got voltage. Ohms is something that you'll see show up in problems a lot. That talks about resistance, so how much resistance something has. Hertz would be frequency. So there's quite a few in here. And like I said, you won't use a ton of these super frequently, but they do show up out there in the world. And some of you might see it with your jobs, like as you're going into the career force next year, you might start to see some of those words get brought up in your jobs every once in a while, and you're going to need to know what they're talking about when they say that. A Henry is inductance. So, do you know what what an inductor would be? Something that like helps transfer heat. So it's like a way of measuring how much it can transfer from like maybe one metal to another metal or something like that would be maybe an example. Okay, so look some of those over. You know, if there's some that you're not sure what they would be, try to look it up sometime, like Google what it means, because it would give you examples on there too, or it would even give you like a chance to see when it would actually be used. So what we're going to finish up with here on the next page is we're going to take just a couple of these random measurements from that table and kind of work with them a little bit. So the first one is saying that 12 nanoseconds is what part of a second. So nano, we actually talked about some prefixes a while back. So if we kind of go back in our notes, I'll try to find it here and see where that might be in section 2. I'll just see if I can pull it up here. Right here. Nano is a billionth of something. So a nanosecond would be 1 billionth of a second. So it's really, 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 really small. So if they're asking you to figure out what would be what part of it, well, 1 nanosecond, I said, is 1 billionth of a second. So 12 nanoseconds, to calculate it, would be to take 12 and then take that times a billionth, which if you're not sure how to write that, it's a really small decimal. It's going to have 0 point, and then there's going to be 8 zeros, and then a 1. So think about, it's basically a billion written backwards. Okay, so a billion has those 8 zeros there. And then equals, if we actually multiply that out, if we take 12 times that tiny decimal, you're going to have point, there's going to be 7 zeros here, and then 1, 2, and then that would be seconds. So it's a tiny, tiny, tiny fraction of a second. So that would be used a lot of times, like nanoseconds and like smaller measurements like that are used when they're talking about how fast even like data can transfer among, like from one area to another area, like through the internet and those kind of things. Some of that travels so fast that it happens before we even know about it. Or even like when you talk about in science, like physics, and they're talking about how fast certain things move within physics. It can go so fast, like we can blink and miss something happening because it moves that quickly. Okay, the last two here, just want to know what are the meaning of the following units. So this symbol here, so if you guys need to go backwards to that chart that I gave you guys, what does that capital A stand for? Yep, which we probably more frequently call it an amp. Okay, if something has like, you know, however many amps. So this has got 115. Now this little symbol in front of that, if we come back to this chart over here, you might see it right here where I'm highlighting in green. It's a micro. So we're talking about a microamp here. So it's 115 microamps. And according to this chart, going back here for a second, it's a millionth of that. So if I wanted to convert it, it would be 0.000115 amps. So it'd be that portion of an amp. Number 2 says 3.2 and then capital M, capital W. What does capital W stand for? A watt. Okay, so let's come back to this chart and find our capital M. Where do you guys see capital M at? What? Mega. Right here. So it's a megawatt, so it's 3.2 megawatts. which is the same thing if we take that, because we said that mega is 1,000,000 times. So if you guys take 3.2 times 1,000,000, it would be 3,200,000 watts. So it's just showing you how you're converting from like a prefix with one of those useful measures that we talked about, and then just going back to like the standard base unit. So just going to a watt or going to an ohm or a hertz or something like that. So you may have to go back. Like I said, I got this chart. This is in your guys' notes for section 2. So you may have to go back to this to see what you're multiplying by. And it does tell you like right here what to multiply by. This has got the decimal. This says, times, and then it's got your zeros with all those decimals. So that's where I got those numbers from, in case you weren't following that. So like this is taking 115 times 0.000001. That's where that would come from. So that's how I got that number there. Okay?